called conditionals. So whether or not if I will do something depends on something else, right? So then we typically use what's called an if statement to try to control whether or not one part of our code is going to be used or when it's not going to be used. And that's pretty important. So we can start with some basic messages so you can see how it works. So let's say that I have something like a mass of an object, okay? And when I consider it as large, which maybe is more than 3, I want it to print to the screen that it is large, okay? So it's kind of how it sounds. So if the mass is greater than 3, and I can say 3.0 if I like, then do something, okay? So if you remember from our for statements yesterday, when we end a for statement, we put a colon. And similarly, when we end an if statement, we put a colon again, all right? And then when I press enter, you'll notice that there's an indentation right there, which is important because that's the then part of the if statement, okay? So if mass is greater than 3, basically I want it to print that mass again, and then I want it to say it's large. All right. So what does that look like if we print it? It's large. All right. So how do I know that this is actually working, right? Maybe it's just always going to print that. Well, what if I give it a mass then that isn't greater than 3? Let's see what happens. So what if I say that it's now 2.07? And again, if the mass is greater than 3.0, then I would like it to print that it is large. Hey, nothing happened. And we know that it ran because remember, when you see that number there, you know that it was successful in running. But yet I don't see anything printed out. So this is showing us then that our if statement is working as we expect. So you can already see how something like this can be chained to other parts of code to start making it things more useful for us, right? Because there's this automatic selection where if something it passes one condition, one thing is done, and now we can start to add other conditions too. Okay. So of course, doing one mass at a time or one data point at a time is kind of tedious. And as we learned before, we can automate things when we start to use loops, those for loops. So let's try to combine our knowledge of for loops with an if statement. So I'm going to have this, what is this again? Remind me. This thing that's between 2 brackets with a bunch of numbers separated by commas. This is a list. Yep, very good. Okay, so then we're going to have this Python list, and then we want it to basically do the same thing, but in a more automated way. Okay, so let's try with a for statement. So for whatever, remember this part doesn't matter. So this is basically just the loop variable. So I'll just say m. So for m in, and our iterator at this point is just the list. So for m in masses, and notice how it's going to go inside of that indentation space. And at that point, I can say for if m is greater than 3.0, and notice again, it's going to indent again. So the nice thing about Python and this indentation is you can clearly see which parts of the code are part of the if statement and which are part of the for loop. Okay. Then we're going to print m is large. Okay. And just as a review, the reason we're putting m here is because this is that loop variable. It's going to go one at a time through each element within the list. So with the first pass, it's going to evaluate 3.54. So is 3.54 greater than 3? Well, if it is, which it is, it's going to say that 3.54 is large. Then next, okay? Next element that in the list, 2.07, is 2.07 greater than 3? If it is, it'll say it's large. Let's see what happens. Okay, and that's good. Basically, it looks like it's working. It picked up our 3.54 and 9.22 as being large. Okay. Did everyone get that? Or any questions? That's our next part. Very good. Exactly. Right. So this isn't really catching everything else, right? The 2.07. We kind of want something like, what about if it's something else? Okay, so very good. That's what we're going to do next. So the next part is, let's modify this code so that, you know, if it's not a 3, then we want it basically to say it's small. Okay, so if the mass is greater than 3.0, we'll say it's large, but otherwise, or else, and let's make sure we put that in line where the if statement was. So otherwise, or pretty much else, we'll say it's small. And else if is coming up too. And there we go. Now we have added another block of code that can handle the other situation when it's not greater than 3. Okay. Let's check about something else, right? So maybe we have something large, something small, but we're not limited to just 2 conditions. We can keep going, all right? It might be, though, that it's important that you want to evaluate something first, like the most important criterion, and then you want it to kind of catch everything, okay? So, for example, you want to make sure that everything that's large is first caught, meaning everything greater than 3.0. Then you want it to evaluate the next step, all right? Basically, you're saying if the mass is greater than 3.0, then print it's large. However, if it's something else, then do the next step, which would be whatever we want. So for example, maybe else if mass is, oops, I'm sorry, I mixed the order up. I'm going to actually downgrade this criteria because for me, whatever these masses are, I have a new criterion of something being not small, not large, but huge, okay? So even more important, I want to catch if something is greater than 9. And then I'm going to consider that as huge. And then otherwise, if it's greater than 3.0, then it's large. And then all other conditions, then say it's small. All right, so we've now added 3 lines to our logic. Basically, first check if it's greater than 9, then print it's huge. Otherwise, if it's greater than 3, so else if, we'll print it's large. And then finally, for any other condition, else it's small.
Is that ELIF intentional? Is that a typo?
Nope, that's it. Else if, it's ELIF, ELIF, whatever. That's how Python abbreviates else if. And there we go. Any questions? Yes.
So let's say we have on our list something like 12. So
Mhm.
will it say 12 is huge and 12 is large?
Oh, good point. So that's the reason we put if and the largest criterion first, because it will first evaluate this. If, like, for example, we put a 12, it's first going to go here and say it's huge, and then that's it. It's not going to continue on. It's once it reaches the condition it satisfies, it's going to stop.
Okay, thank you.
You're welcome. Can you have it tell you all of the huge first, followed by the large, then the small? It's technically doing that, except in the print, it's evaluating one at a time. So if you wanted it to go like huge, then large and small, you can order this list, put it in order, and then run it through this for loop. So I'm kind of curious about the 12. Don't you want to try it? Oh, there you go. Right. So in terms of conditionals, it basically depends on like what you're trying to accomplish. For example, this one is going to evaluate each at a time. There's another conditional called where. Basically with that one, I don't think we cover that today, but basically with where, it's going to evaluate your condition based off like a truth statement. So when something is true, it will continue to do the loop, right? But when it's not true, it's going to basically stop. So it's similar to for loop. I'm going to say that it's, I'm sorry, while loop, not where. I'm getting all my W questions wrong. So while, it's going to be similar to a for loop, but it's going to continue to evaluate until something is false, which it's great if you know how to use it, but if you miss a condition when something is true, it might run forever and crash your program. So for loops, you have a lot more control than the while loops, which is another type of conditional. Okay. That's a good point. And let's try that on the next example. Right? It turns out then that these conditions are going to be evaluated in order. So actually, it does matter where you place these things. Right? So I'm going to put a little quick program to evaluate grades, which might be actually pretty useful for a lot of us if we can automate something like that. So maybe I have one grade point, which now you know we can convert this to like a loop or put it into like a pandas data frame. But just for this example, let's check out a single data point, which is a grade of 85. And let's run it through one of these if statements. And if you're wondering, can we add additional conditions with and, or, and not? The answer is yes. Okay. So let's say our grade was greater than or equal to 90. I'm going to print that the grade is A. Okay. How about what about for more than 80? It's a B. I can do, which one of these should I put? LF, yes. Otherwise, if the grade, or else if the grade is greater than 80, then it's a B. Print that it's a B. Okay, yeah, a little space to make it look nice. And by the way, there's always more than one way to do something. Some of you may think, couldn't I just say if the grade is between like 80 and a 90, it's a B? Yes. In that case, you kind of don't need the aleph. But look at that. With the aleph, we have less code to write. I don't need to say that it has to be less than 90. Why? Because greater than or equal to 90 is already evaluated, already done. So at this point, I don't have to say if the grade is greater than or equal to 80 and less than 90. It'd be redundant because everything over 90 is already done. It's already evaluated because the conditions are tested one time and ordered. Interesting, right? But it depends on your coding style. There's kind of benefits to both. With this one, you see the code is much more concise. Maybe someone can argue that, well, if you wrote if grade greater than or equal to 80 and grade is less than 90, it's more clear to the reader. So it's really up to you which one you decide. But the way we have it here with ELIF, we don't need to specify that it's less than 90. Let's see. Let's try, of course, giving the one more, which would be, let's see. You know, I've seen in some programs that like an 85 was like an A, and others were like a 92 was a B plus. So there's a lot of variation. So you're going to have to change this, of course, to your own use case. And what do we expect this to print out? Well, hopefully it should print out what we expect for 85, which is a B. Any questions about this loop? Or sorry, not loop, this conditional. Good question. What if it was a 45? Is it greater than 90? Nope. Is it greater than 80? Nope. Is it greater than 70? Nope. So we would expect nothing. What could we add to catch everything else? Oops, well, what else? What do you think we can add to catch the other values that aren't here? Greater than 90, greater than equal to 90, greater than equal to 80, greater than equal to 70. What do you think we can add to catch those other numbers? Yep. In fact, we don't even need to specify a condition if it's really meant to capture everything else. We just say else. That's good enough, right? So then we say else print, I don't know, not passing, sadly. All right. Good questions. So far, so good. Okay. How about, well, we did talk about that the order matters. So for example, if I have an example like velocity equals 10, and then if velocity is greater than 20.0, I want to say that we're going too fast. So for whatever application, for whatever application that we're doing. Oops. And otherwise, I want to say that we are now adjusting the velocity. Okay, so maybe this is like a program that's running on some type of drone or something like that. Okay, and then what you can do is also change the value. All right, so maybe within here we're going to change the value to 50. So with this program, if it's greater than 20, it will print that it's moving too fast. Otherwise, it's just going to say adjusting velocity. And then because it's still part of this else statement, it's going to change the value to 50. So, but 50 is now greater than 20, isn't it? So should it say it's going to move too fast? Which one is it going to do? What do you expect it to say? Moving too fast or adjusting velocity? Adjusting, yes. Because the way it evaluates is in order. So it's going to evaluate as else because it's not greater than 20. So it's going to print adjusting velocity. And if you notice with the velocity being set to 50, that's happening after the print. And this isn't within a loop. it's only going to evaluate this one time. All right. And let's find out. You got it. All right. Any questions so far? Time goes so quickly. Okay. I'm gonna quickly see if we want to just skip a little bit ahead to get to the fun stuff. I think we've covered pretty much everything that we need to talk about in terms of how the if statements work. One other thing, just to reiterate what someone already mentioned, is can we use ands or ors? And the answer is yes. Okay, so why don't I have an example? And this one should be in your notes. The code is relatively long, so please don't worry about copying it as I paste it. But this one is right here. So I have some data points, and basically I'm having an if-then statement, or if, elif, else. So that makes sense. Except now we have not just one data point, as in the previous examples, right? So like one velocity, one mass. I want to now loop through each one of these. All right. So basically in the code, the way this code is set up, you notice we have this value being set I equal to 0. Do you remember that concept of accumulator, right? So then this is one way to do that. We can basically loop. How many times do you think this is going to loop? What did that range thing do? 5 times, right? So 0, 1, 2, 3, 4, 5, or 1, 2, 3, 4, sorry. And the reason we're doing that is if mass 0, velocity 0, what's that referring to? That's referring to the index of each list. So mass index 0 is going to be this first element, so with index 0. And velocity 0 is going to refer to this element over here, the 10. Okay? And you notice it's going to evaluate each pair once, and then it's going to go to the next one, because after the range, after it goes to 0, it's going to increase to 1. So mass 1 is referring now to this position. Velocity 1 is referring to this position. And with logic like this, this allows us to go through multiple data points at a time rather than inputting them one at a time, which is way too tedious. So for a use case, you can think about like you have research that you're doing, and then this data is being imported from like a CSV file into Pandas data frame. And then you can have a loop in order to evaluate the data points like this. So if I print something like this, it's going to go ahead and go through each condition. And the nice thing is you can have these else statements to deal with situations that shouldn't be, right? So if you know what the normal distribution and type of data you have should be, you can input those types of conditions. And if something else happens, you can put a check like this. So this one literally says, whoa, something's up. And that may prompt you to check your data. Really important when you're having research data being inputted, there's always a chance of like a typo. Okay, so this one, why did this one pop up? The reason being, let's see, this was 1, 2, 3, 4. Right, so the fourth one, what's wrong with it? 1.86 mass, 25. So let's see what happened. So was the mass greater than 5 and was velocity greater than 20? No, right? And is referring to both have to pass. So is mass greater than 5? No. Is velocity greater than 20? Yes, but are they both true? No. So next. So is mass greater than 2? No. Is mass is it less than 5? Yes. But is velocity less than 20? Nope. And as you go through each one, you'll notice none of these pass. So based on that criteria, it's going to flag it as not being correct. There's something wrong with the data. So you can definitely set up your code to try to look for discrepancies within your research data. You can change it so that actually it won't print everything, but only the errors. So then you can print something like print the index number of where this is messing up. So if you have like 20,000 data points, you can have it print that this is in row 2, column 10. And then you can have like a list of what data points could be issues. So you could automate stuff like that. Okay. Good question. 2 equals. If you're checking if something is exactly equal, you want to put 2 equal signs. The single equals in Python always refers to setting values. So like I equals to 0, you're setting it equal to 0. If you want to check if mass is exactly 5, you should put like double equal sign. I don't think it does. I don't think ampersand works. But you know, let's find out. Nope, didn't like it. Not as flexible as some other coding. All right, great questions. Let's go to challenge 2. I think challenge 1, you're gonna blow it out of the water. Let's try challenge 2. All right. Challenge 2. Look at this code. And thinking about what we've covered so far, what do you think you can change so that you'll have a new list that has zeros when the original values were negative? And when they're positive, keep the original value. And if, of course, if you think of other questions, please also let us know. Oh, you know, just to give some context, you should expect something like this. Should be the output you would expect. Okay. And yes, thank you. Please put those green check marks once you got it. Okay, I think we're getting it. So then let's see. What should we change? Well, if you remember from yesterday, when we're going to have this loop and we want to store it, we should first initialize something blank. So how should we initialize a blank? And this looks like we're making a list. So a blank list, what do we want to put? Yep. Thank you. And what were we checking? We wanted to give it a 0 if what? When the value was less than 0. Otherwise, we wanted to give what? We want to append what? Yep, we want to give it a 1. So we're using that list method to append new values, and looks good. Any questions? Okay, one more challenge, and then we get our little break. Oops, let me put it down here. Let's check out challenge number 3, which will be something that looks familiar. For this one, the code is definitely long, so please refer to your learner notes. Does this look familiar? This is a plot. So we were working with plots yesterday, and now we can see how we can combine this if, else type of conditionals to try to do something else with our plots. All right. So basically the idea is change this so that, and you will also see these instructions in your notes, but basically change this so we can have different colors based off mass and velocity. Right. So if that's your code, then some instructions would be like that. All right. And you can already see one of them, everything else that doesn't satisfy these conditions would be yellow. But how about if the mass is greater than 5 and greater than 20? You'll notice just like this, it's going to be red. So similar to this one, can you fill it out so we get blue and green? It might be getting pasted like right now. It's part of the learner notes. It's an additional example that we created for, yeah, all the way at the bottom. Thank you. All right. And when you got a nice working graph, let's have the green check mark go up.
Can you guys see challenge 3 on the learners?
I can see it.
You can?
Mhm.
Okay, perfect. Thanks.
It's in the wrong place though, I guess.
Okay, yeah.
All right, good. Starting to see some green check marks here.
Okay.
Just a handful.
Okay, I'm seeing a lot. Okay, looks good. All right, let's go through it. Okay, so it's going to follow a similar pattern as this one, but it should satisfy the next condition. All right, so for blue, we wanted it to be when mass was greater than 2 or less than and equal to 5, as well as velocity being less than or equal to 20. So did you get this one? And then for green, we want it to be less than or equal to 2 and velocity less than or equal to 20. And again, the reason we have these eyes right there is because it's going to evaluate each pair one at a time. Did everyone get a nice pretty graph? Look at that. So with that, if you have some kind of condition or you need to color code, depending on some type of categorization, this would be a good use case for that. All right, any questions? Okay, why don't we have